Hello and welcome back to the Arduino Python series, and this is the tutorial number 26. In the last couple of lessons we built some pretty cool HMI dashboards for our motor projects. Today we are going to practice those skills again because the best way to get comfortable with Matplotlib and data visualization is to build lots of different dashboards. So we will be working with a Hall effect sensor. It's a device that detects, it's a sensor, that detects, magnetic fields. This sensor has two outputs, an analog voltage that tells us the strength of the field, and a digital output that goes high or low, when a certain threshold is crossed. So we will use the analog reading to position a servo motor, and we will create a dashboard that shows a dial with a needle showing the servo angle, just like a speedometer that we did in previous lesson. And also we want a horizontal bar that fills according to the magnetic field strength. Also a circle indicator, for example, that lights up when the digital threshold is triggered. Also a counter that counts how many times per threshold has been triggered. And we can also add an RGB LED that changes color based on the field strength and trigger. This is a fantastic way to practice building HMIs. You will see how easy it is to add new visual elements and link them to live sensor data. So let's get started. Okay guys, let me explain to you about today's hardware, setting up the hardware. So this is my SMD RGB. So it doesn't matter if you don't have a module, you can use three separate LEDs. It doesn't matter. Okay, so I'm gonna install it on my breadboard. Okay, and this is my Hall effect module. Okay, with 4 pins. The first pin is the A0. The second one, as you can see, I don't know. Okay, so the second one is G, or the negative. The third one is plus, or VCC, and the last one is DO. Okay, so now let me just connect it here by my SMD module. Okay, all right, this is the sensor. This is the Hall effect sensor that detects the magnetic field, and with this knob you can change the sensitivity of your module. Okay, now, and this is my servo. Okay, this is my SG90 servo. So because it's a small servo, you can connect it directly to your Arduino board. Otherwise you need a external power supply. Okay, so my Hall effect sensor. So this is the analog pin. Okay, so the analog goes to the A0 pin on my Arduino board. Okay, so okay, the A0 goes to A0 of my Arduino board. Okay, and the second pin is the G. Okay, so I'm gonna connect the G. Okay, this is the G, so I'm gonna connect it to the negative of my breadboard as usual. Okay, so I'm gonna, because I want to connect the GND and the VCC, the 5 volts of my Arduino board, to my breadboard. That's why I connected here. The third pin is the positive, or the VCC, so I'm gonna connect it to the positive of my breadboard. And the last one is the digital pin, and I'm gonna connect it to pin number 2 of my Arduino board. Okay, so I'm gonna connect this one to pin number 2012. Okay, this is pin number 2. Okay, so now let's just start wiring our RGB module. Okay, So the red goes to pin number 5 because today we want to just use the PWM. Okay, we want, for example, to change the colors. It doesn't matter, you can use the normal pins, you can use the digital pins. It's completely, up to you. It doesn't matter if you don't want to use, the PWM pins, so you can use, digital pins. It's okay. So red goes to pin number 5, and G goes to, G is the first one from here. Okay, RGB. So G goes to pin number, pin number 9. Okay, 9 is also 8. 9 is PWM, has the PWM capability. And the red one, okay, the red can goes to pin number, the blue. The blue goes to pin number 6. Yes, so blue. Okay, blue is the last one here. Blue can goes to pin number 6. Okay, so this one is the A0. Sorry, it came out. Okay, just be careful. Okay, came out. And the last one on my RGB, so will be, the negative. Okay, so the negative connect to the negative of my breadboard. Okay, now it's time only the servo motor. So I have to just, as you already know, the servo has 3 wires. The yellow one goes to it has to connect to my Arduino board, and I'm gonna connect it to pin number 3. Be careful, it has to be, the pin has to have, the PWM capability. It's very important. So the yellow goes to pin number 3. Okay, all right, pin number 3. And the red one or the middle one is the positive. Okay, so goes to the positive of my breadboard. Okay, and the brown one or the last one is the negative, and the negative also connect to the negative of my breadboard. All right, so everything's finished now. Just we're gonna connect as usual the 5 volts. Okay, the 5 volts go to the positive of the breadboard, and the GND also goes to the negative. Let me connect it. Okay, and the GND also connects to the negative of our breadboard. Okay, so this is for setting up the hardware. So we finished setting up our hardware. Now we can just go and start coding. All right, now let's start coding. Okay, so the first step, as usual, is to just create a new file. Okay, I'm just going to create a new file. Sorry, I just mistakenly I pressed a new folder. I have to click on new file. Sorry. So I'm gonna say like hall sensor.py. Okay, so first of all, we start with imports. Everything is familiar for you now, but just note we import patches and numpy again. So I'm gonna say from mata import. I'm gonna import our Arduino and util. Okay, next I'm gonna import our time library, and then I'm gonna import matplotlib.pyplot as plt, and I'm gonna import matplotlib dot matplotlib dot patches as patches, and the last one, the numpy. So I'm gonna say import numpy as np. Okay, all right, so here in this part, in the first part, so we're using the same libraries, as before. Patches, helps us, draw shapes like rectangles and circles, and numpy also, helps with math, like generating angles for the dial, right? The next step is to set up our Arduino board. So I'm gonna start with the port. I'm using port cam number 9, and I'm gonna say board Arduino through each port, through port number 9, and I'm gonna just start our iterator. So iterator, I'm gonna say util dot iterator. I'm using on our Arduino board, and I'm gonna say iterator dot start open and close parentheses. Okay, next we come and define our pins. So I'm gonna start with our Hall sensor. So I'm gonna say Hall. First of all, I'm gonna define our analog pin. So Hall analog. I'm gonna say board dot get pin. Okay, so I'm gonna say, so it's analog. Be careful, don't say D. It's analog, so that's why I say A0, and our sensor act as an input. So I'm gonna say A0I, and now I'm gonna say Hall. So this time the digital pin, I'm gonna say board dot get pin. Okay, as I said, it's digital. Okay, digital pin number 2, and again act as input. Okay, now let's just define our servo pin. So I'm gonna say servo board dot get pin. Okay, so our servo is digital pin number 3, and act. So this time, this is the first time that we want to do this. So I'm gonna say S stand for servo. Okay, so it means that we use servo at this pin. Just be careful that your pin should have, should have the PWM capability. Now let's define our RGB, SMD. So I'm gonna say R for red. So R for board that again get pin, and this time I'm gonna just say D. So the red color is at pin number 5. Okay, so D5P. Okay, P stands for PWM. Now the G for green, so I'm gonna say board dot get pin, and this one is at pin number 9. Okay, so D9 again P. Okay, and I'm gonna say RGB. Okay, for blue. Okay, so I'm gonna say board dot get pin, and I'm gonna say again D, this time pin number 6, and again P, so P for PWM. So if you can remember, we have to enable reporting for our input. So here we have two, analog and digital input. So we have to just enable the reporting for them. So I'm gonna say Hall analog dot, so I'm gonna say enable reporting open and close parentheses, and I'm gonna say Hall digital dot enable reporting open and close parentheses, right? We did this. We enabled reporting to just get continuous updates. If you can remember, we just explained all these things, in much more details, in previous lessons. Okay, so here we finished, setting up our pins. Now it's time to just start setting up our dashboard. So the first step in setting up the dashboard is to just turn on, an interactive mode. So how we can do that, if you can remember, I can say plt.ion open and close parentheses. Okay, and after that I have to create, a figure with like a custom size. Like for example today, how I can do that, I can say fig and comma ax. Okay, exactly like the previous lesson. I'm gonna say plt dot subplots. Okay, open and close parentheses, but I want to just create something with a custom size. How I can do that? I can say fig size, okay, equal. Now I'm gonna give it, the size, so like 10 inches to 6 inch. Okay, I think it will be enough for today. It will be big enough, but we can come back and check if it will be too small or if it will be too big. We can just change these numbers. It's okay. After that, we have to set, access limits, for example, from 0 to 100. How I can do that? I can say ax dot, if you can remember, we had to use built-in functions, set xlim and ylim. They are the built-in functions. So set xlim from, as I told you, from 0 to 100, and we're gonna do exactly the same thing for the y direction. Set ylim from 0 to 100. Okay, and I want to hide the axis. Okay, how I can do that? I don't want to see the grids or to lines, so I can say ax dot axis. Okay, and I'm gonna say off. Okay, just one more thing. I want to have a black background. I want my background to be black. Okay, so I'm gonna say fig dot patch dot set face color. Okay, so which color I want my face color to be black, but it depends on you. If you want any other color, just you can define here, right? Okay, so the next step, I have to define the servo dial. I want to define a semicircle. Okay, like the previous lesson we had two semicircle, but today we want to have only one semicircle. Okay, so the first one I have to say, give the coordination of the center of my of my dial. Okay, so I'm gonna say dial center. Sorry guys. So dial center, 50 50. What does 50 50 means? The first 50, the first number for the x coordinate, and the second number is for the y coordinate. So I tell my program to just set the center of my dial at 50, 50x and 50 y. Okay, now I want to give the radius of my dial, so I'm gonna say dial radius. Okay, I think again I'm gonna just choose 40 because in the last session we chose 40 and it was okay. It was nice. Now I have to define. Now it's time to use our a numpy. So I'm gonna use theta. I'm gonna say theta. This is my variable. Okay, because we have to just define the two coordinate, the x and y coordinate of our semicircle, and we have to use that the formula that I explained to you. So first of all, I have to define the the degree in radians. So I'm gonna say theta, and I'm gonna say np dot lin space. Okay, np dot lin space. Okay, so from pi to 0. Okay, so I'm gonna say np dot pi, right, from pi to 0, and I want 100 steps between this pi to 0. And now it's time to give the x and y coordinate. Okay, so if you can remember, we had to use the formula. What did we so far here? So we just create a semicircle dial centered at 50 50 here. Okay, and the radius of the semicircle is 40, exactly the same technique as lesson number 25. Now here we have to define the x and y coordinates of our semicircle. Okay, so I'm gonna say x1. So now I can say dial center. Okay, so I'm gonna pass it 0. Okay, because it's the x, and the x is the first argument, and the first argument in Python is start from 0. So plus del radius times np, that for the x we just multiply it by the cosine of theta. So I'm going to say np that cosine theta. Okay, and now for the y direction, so I'm going to say dial center. Okay, I'm going to pass it 1. Okay, and I'm going to say dial radius times np, that this time for the y direction, so we're gonna multiply it by sine of theta, sine theta. Okay, right. Okay, now we just created 2 point. Now we have to just connect these 2 points. So how we can connect them? I'm gonna say ax dot plot. Okay, so I'm gonna use these 2 x and y that I created. I'm gonna say plot x, y. All right. What color I want? I want, for example, because my background is black, so I think white will be a good option. So I'm gonna say white, and the thickness of our line I want to be, for example, like 2. 2 is enough. Okay, and the only thing that is left here is the needle. Okay, we have to define the needle, but we do not pass any coordinate, any xy coordinate, because we will update it in our main loop later. Okay, so I'm gonna say needle line. This is exactly like the previous lesson, guys. That's why I am just doing it a little bit more fast. Ax, because we explained all these things in very much more details in previous lesson. So this lesson is just kind of a preview. So ax dot plot. Now, as I told you, we don't pass any x and y coordinates, so it's empty. But the color I want it to be like red. Okay, and the thickness will be like let's say 3. Okay, the thickness of the needle will be 3. Okay, so this is for the servo dial, right? So now we can just print something, print a message, a text, for example, inside of the semicircle or outside. We will just decide. So now we can do that. So I come to the next line, and I'm going to create a new variable. I'm going to call it like angle text. Okay, so I want to see the text to print the message exactly in the middle of the dial, in the center. So here I mean dial center, but as you can see, the dial center, it's a tuple. Okay, but in order to use it here we have to just unpack it. Okay, so if we can remember, there's a trick in Python to unpack tuple. So I'm gonna say ax dot text. Okay, so what was the trick to unpack the tuple? The trick was to use asterisks before the tuple. So now I can say dial center. Okay, so it means that we unpacked this tuple instead of just unpack it directly here. We just I added an asterisk, and then I called the dial center. Okay, dial center. So and initially I want, for example, to see like 0 degree. Okay, let's say 0 degree. Okay, and I want to just give it the horizontally and vertically alignment. Okay, how I can do that? I can say, if you can remember, I can say HA and VA. So HA. Okay, so HA equal to, again, center. Okay, and I can say VA also equal to center, right? Okay, now let's put a comma and go to the next line because it will be too long. And now we can define the font size. Okay, the font size will be like 40 we can come back and check. We can just run the program and check if the font will be too big or too small. Again, we can change it, no problem. And the color of the font, I want it to be white. Okay. And the last one, for example, let's make the text bold. So I'm gonna say font weight. Okay, font weight, and I'm gonna say bold. Okay, so that's it. That's for the servo angle text. Okay, I don't think that anything's left here in the angle text. Okay, so we can go to the next stage. So as I told you, at the beginning of the video, I want to see, the whole, for example, something like, whole analog bar. Okay, so like, a rectangle to, show us the magnetic field. Okay, so in order to do that, we have to define it here first. Okay, so as I said, I want the bar to be like a rectangle. Okay, so the rectangle has a width and has a height. Okay, so the height will be always the same, but the width, will change during the, because as I told you, as the magnetic field change, the width of the rectangle also will change. So the height will be the same, but the width will just change. Okay, so now let's start with the height. I'm gonna say, for example, bar height. Okay, so I'm gonna give it like bar height 8. Okay, 8, I think it's enough, but we have to check. And let's just define the rectangle of our whole analog bar. Okay, so let's call this variable like bar rec. So bar rec stands for example, bar rectangle. So I'm gonna say in order to create shapes, if you can remember, we had to use patch library. Okay, so I'm gonna say patches that rectangle. Okay, so patches that rectangle. I have to just give it the coordinate, start from where. Okay, for example, let's say start 10 10. Okay, 10 in x direction and again 10 in y direction. Okay, so at the beginning, the width, the width of our rectangle will be 0. Okay, because we assume that we don't detect any, our sensor don't detect any magnetic field initially at the beginning. After that, we have to define the height. So the first we have to define the width, and the second the height. So the height we just defined here, we put it in a variable, so we can call this variable, I can say a bar height. Okay, so bar height. And now I want, for example, I want it to be like cyan. Okay, so the color will be cyan. Okay, the color will be cyan. So this is the coordinate. Now we have to just connect these coordinates together. Okay, exactly like what we did here in the, okay, see here in this dial. Okay, so we just defined the coordinate and then we connect it together. The coordinate, we connect all the coordinates together. So we can say ax dot, now I can say add patch, add patch. Okay, and we call our variable. Okay, so I'm gonna say bar rec. Okay, that's it. And let's just but here we printed a message, a text in the center of our dial. Here we can just print, for example, something to show for the user. For example, tell them this is the magnetic field. Okay, so I can say bar text. Okay, exactly, we're gonna do exactly what we did here. So I'm gonna say ax dot text. Okay, so ax dot text. Now instead of just giving it because we didn't define any variable for it, so we don't need to unpack anything. So we don't use any asterisk. I'm gonna just pass it, the coordinates. So I'm gonna say 10, like, or with the position, 10 in x. The x will be the same, but for example, above, above the rectangle. So it will be 10, 20, and we're gonna say, the message will be, the text will be magnetic field. Okay, so magnetic field. So it's 0 at the beginning, right? Now with the size of font size, like let's say this one, we can see in 12. Okay, and the color we also just again say cyan. Okay, so the color also will be cyan. So what we did here, these 4 lines, we create a rectangle patch, a bar that will grow, horizontally as the magnetic field increases. Its width, its width starts at 0, and it will just increase, as the magnetic field increase. We also add a text label here, at the with the end, with the last line. So we add a text label below it to show the percentage. I want also, to create, a small circle that will turn, for example, yellow or red or whatever color you want when the digital, threshold is triggered. Okay. Also, I want to just print a text, above this circle that will display, for example, a text like trigger, when the trigger active. Okay, so how I can do that? Again, it will be exactly like, the one that we did here. So let's do it one more time again here. But this time, instead of rectangle, it will be a circle with, for example, diameter or the radius like 10 or 8 or something like that. So I'm gonna say trigger circle. Okay, trigger circle. Okay, so I'm gonna say again patches dot, as I told you, it's circle. Okay, patches dot circle. Now with the coordinate of like I want to show it in top at the right side. So I think it would be like 85 and 85. Okay, 85x and 85y, and with the radius of 5. Okay, so the second number here will be the 5. Don't think that it will be the third, because these two numbers, the coordinate, we count it as the first, and the size will be the second. So 5 will be the radius, and the color. Okay, with at the beginning I want to see, for example, something like again gray. Okay, so gray, it for the time that no it doesn't trigger, so the sensor doesn't trigger anything, and later we will update the color. So now we just created it, so we have to add, this use this built-in function, this add patch, in order to create it, in order to add it to our figure. So I'm going to say ax dot add patch, and I'm gonna just call this a variable that I created here. So I'm gonna say trigger circle. Okay, now as I told you, I want to also print a message, print a text. So I'm gonna say trigger text. Okay, so I'm gonna say ax text. Okay, like for example, first I'm gonna give it the coordinate. I'm gonna say 85, but this time I'm gonna say 92. Okay, so it will show above it. Okay, so 85, 92. Okay, at the beginning nothing, so nothing at the beginning. Okay, because we want to update it later in our main loop. And let's just adjust it, horizontally and vertically. So I'm gonna say again, I'm gonna use HA. Okay, so I'm gonna say center. Okay, and VA also. Good, we will say center. Okay, and the color this time, let's say color. So color will be like, okay, yellow. Yes, the color of the text will be yellow. Okay. The font size also. Okay. Now I think it's too much. Let's just, after this comma, let's go to the next line. Okay, so comma, color yellow. Also we're gonna say font size will be like again like 12, like this font size. Okay. 12, and let's make it bold too. So I'm gonna say font weight. Okay, so I'm gonna say bold. Okay. All right, so now we also finished, creating the digital trigger indicator here as well. Okay, just one more thing left. As you know, we also have a counter to just count the trigger. Count the how many times that the trigger just activated. Okay, so at the beginning, our counter at the beginning is 0. Okay, but we want to just print a text, and say, for example, like threshold count, and then we just want to print the count. So let's just create that text. So I'm gonna say counter text. Okay, it will be exactly this trigger text, guys, or this bar text, with no difference. So I'm gonna say ax dot text. Okay, so let's give it the coordinate first, like for example at the 80x, but at the bottom right side of our figure or our canvas. So I'm gonna say 80 but 10 in the y direction. And so I want to say, for example, threshold count. Okay, so will be 0 at the beginning. Okay, now let's say for the font size. Okay, font size will be again 12. Okay, font size 12. Let's go to the next line. Font size 12, and the color. Okay, color will be like this one also yellow, I think will be fine. Okay, and let's make this one bold as well. So I'm gonna say font weight. Okay, font weight bold. Okay, that's it, guys. So our counter also get finished, right? So I think nothing's left here. Now we can go and just define our helper functions from now on. Okay, if you can remember from lesson number 25, I had I have a helper function in that lesson called draw needle. So I have to define exactly almost the same thing here, but here I need a helper function that calculates where to draw the needle on the semicircular dial base on a given angle in degrees. Okay, so how I can do that? Let's just define the function first. For example, I'm gonna say def, and I'm gonna call it like angle to needle. Okay, this is just the name of my function, and I have to just pass it one argument. The argument that I want to pass it, I'm gonna call it like the argument that I want to pass. The argument is angle degree. Okay, so this this angle degree, this is an input. So this is the desired servo angle in degrees, ranging from 0 to 180. 0 degree means that the servo is at one extreme. 180 degrees means at the other side. Okay, so in our dashboard, we want the needle to point to the left at when it is at 0 degree, up at 90 degrees, and right when the servo is at 180 degrees. So this matches the typical orientation of a semicircular dial. So in order to do that, the first step is to convert degrees to radians. Okay, how we can do that? This is the formula to convert degrees to radians, or if you want to convert radians to degree. But today we want to convert the degrees to radians because our servos is in a degree. and we want to show it in our dashboard, so we have to convert it to radians. So we're gonna do exactly, like this formula in our code. Okay, so how we can do that? First, I can say, okay, so I can say np dot pi. Okay, this is exactly, the formula that I showed to you, and so it's pi time angle degree. Okay, now I'm gonna divide everything by 180. Okay, but there's a problem. If we use this directly, at 0 degree angle would give, 0 radians. So which points to the right, since, on a unit circle, if you can remember, or if you know now, angle 0 is along the positive x-axis. But we want the 0 degree to point to the left, okay? To point, for example, to the negative x. So what can we do now? So now, in order to do that, we have to subtract, this value from pi, or from 180 degrees. So in this way, we flip the direction. What I mean, this whole formula, okay? So I'm gonna say np dot pi, okay, minus this whole formula. So this is, how we calculated, how we just converted the degrees to radians. But now we have to calculate, if you can remember, the tip of our needle. Okay, so we have to calculate, the x and y direction of our needle. Okay, so again, in order to do that, we have to use the circle, formula. Okay, so I'm gonna say x equal to dial center. Okay, dial center. So for the x direction, I'm gonna pass it 0. So dial center 0 plus dial radius, okay, time. Now I'm gonna say np dot cosine, but this time I'm gonna say I have to just pass in this cosine the theta. Our theta will be here. Okay, this whole formula, but I don't want to put this whole formula here, so I'm gonna put the whole formula into another variable. I'm gonna call it, for example, like angle rad. Okay, so I'm gonna put the whole formula into this variable, and I can now easily call this variable here. So in order to just use this whole formula. Okay, so this is for the x coordinate, and now one more coordinate, the y coordinate. So I'm gonna say dial center. Okay, I'm gonna pass it 1. Okay, just I don't need, it doesn't matter if you just add in the space, but you don't need to do that. So and now I'm gonna say dial radius. Okay, time np. This time I'm gonna say sine, so our theta, or our degree. So I'm gonna say angle rad. Okay, so if I want to just explain a little bit more here, this n pi, np cosine and sine, angle rad, it gives these two give the coordinates of a point on a unit circle. Assume that with the radius 1 at that angle. Okay, at this angle, right? And we multiply these two, we multiply it by this dial radius, so it scales each to the size of our dial, and then we just add it to this dial center. Okay, with these two dial center, so it shifts the point from the origin to the actual dial position. Okay, so x and y becomes the point on the semicircular arc where the needle tip should be. Okay, now for the last step, we have to return both ends of the needle. Okay, so how we can do that? If you can remember, now we have to use return. Okay, return, and we can say, okay, open the bracket. So I'm gonna say dial center. Okay, dial center. So for the x coordinate, I'm gonna say 0 and x. Okay, so this is for the x, and for the y, I'm gonna say again dial center. Okay, this time I'm gonna give it 1, and I'm gonna say Y. Okay, so the needle, the needle is a line from the center of the dial to the tip that we just calculated here. These two X and Y for the tip of our dial, for our needle, sorry. So we returned two lists. With this return, we returned these two lists. Okay, these are two lists. So first list, this list, the first list, the first list, it's all X coordinates of the line. So, center X and tip X, I mean with this, center X and tip X. And the second line, sorry, the second list is, all Y coordinates of the line. I mean, center Y and tip Y. So, this, what did we do here? This angle to needle, this helper function. This is a compact mathematical way to translate an angle, I mean from 0 to 180 degrees, into the two endpoints of a needle on a semicircular dial. So it hides the trigonometry. So the main loop can simply ask, where should the needle point for this angle, and get back the coordinates to update the plot. So here we finished creating, the first function. Okay, so now only the one more function left. So now the second function we want to create, it's for our, SMD RGB. So I can say def, and I'm gonna call it like set R, so RGB. Okay, and I'm gonna pass it, 3 arguments for R, G, and B. Okay, but why I just wrote everything in capital? Because here I just put these variables in small, so I have to just put them in capital, otherwise it will just give us an error. So now I'm gonna say R dot right, and I'm gonna say R, I pass it R, and now I'm gonna say G dot right, I'm gonna pass it G, and the last one I'm gonna say B dot right, and I'm gonna pass it B. Okay, so this is it. This is for the second function. It was so easy. Now we can go and just create our main loop. Okay, so we're gonna start with our try block. So in our try block, we have to just define some initialization. I'm gonna say a global, like global angle at the beginning. So I want to start my servo at 0 degree, we imagine. So now I'm gonna say previous trigger. Okay, this one also false. This one, it helps, false. Okay, false. So this helps us to detect rising edge of the digital trigger. And one more variable is for our counter. So at the beginning our counter will be 0. Now I'm gonna say while true is true. Okay, so the first step is to read my Hall sensor. So I'm gonna say Hall val. Okay, so Hall val, I'm gonna say Hall analog dot read, because it's input, so I have to say that read. Okay, so what if at the beginning I don't write anything, I don't read anything on my Hall sensor. I'm gonna say if Hall val, if Hall val is none. Okay, so if Hall val is none, I'm gonna say Hall val equal to 0. But guys, tonight I want to just introduce a new way to write this line. Okay, you can write it in this way. For example, instead of writing that, you can just write everything in only one line. How you can do that? I can say you can say Hall val, okay, equal to 0. Now you can just write your if condition in this line. You don't need to just go to the second line. So in this line you can write your if condition. You can say if hall val is none. Okay, so if hall val is none, okay, so this is the if condition. It means, you know, hall val equals 0 if hall val is none, and you can say else hall val. Okay, so I just wrote everything, you know, instead of writing 3 lines, I wrote everything in only 1 line. So and now, you know, I want to keep everything, for example, between only 0 and 1. So in order to do that, you know, if you can remember in previous lessons, we used a trick, a method, you know, called, you know, clamping. So this clamping ensures that a value stays within a specified range. You know, in our case, as I told you, we want to keep everything between 0 and 1. How we can do that? I can say, you know, hall val, okay, hall val equal. So what was that, you know, clamping method? The clamping method was saying, you know, min, okay, so instead of this min, I can use another max. So this max will be hall val and 0. So this is the first argument, you know, this max, it will be the first argument for our main, and the second argument will be 1. Okay, so the maximum has 2 arguments, hall val and 0, and this maximum, you know, itself, the whole max, will be the first argument for our main. Okay, you know, this maximum hall val and 0, it compares, you know, hall val with 0 and returns, you know, the larger of the two. You know, I mean, for example, if hall val is less than 0, example, for example, like negative 0.2, max will return 0. And if hall val is 0 or greater, it returns, you know, hall val unchanged. Okay, but this main, you know, this main, it takes, you know, the result from step 1, from this step, okay, from this max, it takes, you know, the result from the max and compares it with 1 and returning, you know, the smaller of the two. This is how this, you know, clamping method works here. Okay, so the last step, we have to map, you know, the 0 to 1 range to 180 degrees for the servo. How we can do that? It's very easy, guys. So I can say servo angle. Okay, servo angle. So I have to convert it because it will be a float number, so I have to convert it into integers. So I say int, I say hall val, okay, times 280. So this is, you know, this line, it just maps, you know, the 0 to 1 range, 0 from 0 to 1 to 0 to 180 degrees for our servo. Okay, so this is you know, to read the analog part of our sensor. So now we want to read, you know, the digital part, or to you know, determine the trigger of our sensor. Okay, so in order to do that, again, exactly, you know, that I read the analog, you know, part of our sensor here. So now I also have to, you know, read the digital part of our sensor. So I'm gonna create another variable. I'm gonna call it like trigger. Okay, so I'm gonna say trigger equal to, now I'm gonna say all digital all digital. Okay, all digital that read, open and close parenthesis. Okay, now I have to just use another if condition. I want to say, you know, if the trigger is true, and if the previously, you know, in the previous state of our trigger is not true, okay, it means that you know, now the sensor triggered, but the previous state of our sensor was not triggered. Okay, this is the condition that I want to define. So I'm going to say if trigger and at the same time I can say and not previous trigger. Okay, you know, here this prev trigger I'm using this variable that I defined here. Okay, so so I'm saying if this condition is true and this condition is not true, okay, this is what this line means. Then what can we do? then we will increment the counter. We will increment this counter that we defined here. So I'm going to say counter, I'm going to say plus equal to 1. Okay, and at the end of this condition, as you can remember, if you can remember, uh, uh, initially the previous trigger was false. Okay, so now with this condition we just say if this condition is not true, okay, it means that we updated this variable. So now at the end we have to tell our program that we want to update our previous trigger, this condition, this variable, if it's not true. How I can do that? I can say previous prev trigger. Okay, now I'm gonna give it the new value. Okay, so here how I can just update this previous trigger. This is how I can update it. So a previous trigger equal to this trigger. Okay, so what we did here, we just we detect a rising edge, in this if condition. We detect a rising edge and increment the counter. So this counts each time the magnetic field crosses the threshold. All right, now after all this, if all this condition is true, now we have to just move our servo. Okay, how we can move our servo? I can say servo dot right, but instead of giving it any degree, any number, I'm gonna use this servo angle, this variable that we defined here. Okay, so I'm gonna pass it servo angle. Right, now here this global angle that initially it was 0, we can now update this variable as well, like we updated this previous trigger here. So I can say global angle. Okay, so now global angle equal to servo angle. Okay. Okay, so after this, we can easily come and update our dashboard, like the needle, the bar, and if we have any other things. So let's start with the needles. We have X and Y coordinates. I'm going to call it like X, and I will add an N, just for example, it's an abbreviation for needle, and I'm going to say YN. Okay, so X and Y coordinate. Now it's time to use our function, this angle to needle function. Okay, and as you can see, this function has a one argument. Okay, so I have to pass the function an argument. What argument I have to pass it? I'm gonna pass it this servo angle, this servo angle. Okay, so I'm gonna call the function, I'm gonna say angle to needle, and I'm gonna pass it the servo angle. Okay, and now just let's draw it. Okay, so we just gave it the coordinate. Now I have to say needle line. Okay, needle line dot set data. Okay, set data, and I'm gonna pass it to sorry, xn and yn. Okay, so I passed it the two coordinates that I created here, and the last one I need to update the text. Okay, so I'm gonna say angle underline text that, sorry, this angle, I think we created the angle text. Yes, see this variable. So we need to, at the beginning it was 0 degree, so now we have to update this angle text. So I'm gonna say angle text. Okay, dot set text. Now I want to use f string. Okay, so what what I want to see, I want to see the servo angle. I want to see this. I want to see this, you know, this number, the servo angle. So I'm gonna pass it servo angle, and at the end, for example, let's print DEG, you know, stand for degree, for example. Okay. So here with these three lines, you know, we compute the needle coordinates and update the line. Also, you know, update the numeric angle text. Okay, so this is for the needle, and now we can go and update our rectangle. Okay, the bar, you know, the rectangle bar. So how I can do that? I can say bar rec. Okay, so bar rec dot set. Now we have to just set the width of our rectangle bar, because the height is always constant. We defined it, you know, we defined at top and above, you know, at 8 pixels. So now I'm gonna say whole val. Okay, this is for the width, but you know, guys, we want to create a horizontal bar that visually represents the magnetic field strength. So when the field is weak, for example, when the Hall val near to 0, the bar should be very short, and when the field is strong, like, you know, when the Hall val near to 1, the bar should be long, you know, ideally, you know, filling a significant portion of the dashboard. Okay, so here earlier in our code, you know, here, you know, we defined this. Let me find it. We okay, see here. So in the bar rec, this here, you know, we just we created a bar as a rectangle patch. So you know, this 10 10, this x and y, this 10 10, it means that it's for the bottom left corner of the rectangle. You know, it means it the bottom left corner will be at x10 and y10. And this 0 means that the initial width is 0. So the bar starts invisible. We don't see anything at the beginning. This bar height, okay, bar height that we defined here, and we just made it constant here. We said 8 pixels. It's the height, it's fixed, you know, at 8 pixels, because as I told you, we defined this variable here. We said 8, so we used it here. Okay, you know, the bar will grow to the right from its starting point at x10. So the final x coordinate of the bars, you know, right edge will be 10 plus width. Okay, because it starts from 10. And you know, the width will be the whole width, when it's, for example, 1, will be 10 plus width. Okay. But where should the bar end? You know, we want the bar to have a maximum width maximum width that looks good on the dashboard. Looking at our axis limits, we set our axis limits here. You know, see the axis limit, we said, you know, 0 and 100. Okay, so the x-axis goes from 0 to 100. We placed the bar's left edge at x10 here. You know, we placed it at x10. So if we want to fill most of the available space but not hit the edge of the dashboard, we might choose a maximum right edge around, for example, x90. Okay, so that gives us, for example, a nice look, you know, visible bar without touching the right border, you know, of our, you know, canvas. Okay, so you know, in another word, the maximum desired width will be 90 minus 10, and it will be 80 pixels. Okay. So now we have, you know, whole val here. Okay, so now here we have whole val, you know, that ranges from 0.0 to 1.0, but we want the bar width to range from 0 to 80. Okay. How we can do that? You know, the simplest way is linear scaling. So we can just say whole val, you know, time 80. This is how we can scale it. You know, it means that, you know, the maximum width of our, you know, rectangle will be 80. Okay, so after creating this, we have to update, you know, the text. Okay, see, come here. So this bar text, okay, we have to update this, you know, bar text. Okay, so now in order to update that, I'm gonna say bar text dot. How I can do that? I can just again set text. Okay, set text. Right now, before everything, I put an F string. Okay, so I'm gonna say magnetic field. Okay, magnetic field. And in curly brackets, I'm gonna use this whole val, this whole val, but I want to see the percentage. So in order to see the percentage, I have to just multiply it by 100, but I don't want to see any floating number. I want to see integer. So I'm gonna say int whole val. Okay, whole val now time 100 because I want to see percent. And at the end I can just see, I can print percent sign to just show the user that this number is in percent. Okay, so now the next thing that we need to update here, I need to update our trigger. Okay, I mean, for example, I want to say when the digital trigger is active, the circle, the circle that we defined above here, trigger circle. Okay, so this circle turns yellow and the word, for example, like trigger, appears above it. Okay, otherwise just leave it to stay gray and the text is empty. Okay, now let's define it. I'm gonna say if trigger is true. Okay, so what's gonna happen now? I'm gonna say trigger circle. Okay, dot set, I want to change the color, so set color, I want it to become yellow. Okay, now I also want to print text, I mean to update the text, so trigger text. Okay, trigger text dot set text. Okay, and let's say, for example, we want to see like trigger. Okay, but what if it doesn't trigger anything? So else means if a trigger is not true, then I want the trigger circle to be, to stay gray. Okay, set color, so I'm gonna say gray, and trigger text that set text. Okay, it will be empty. Okay, so this is it. And now let's just go for our counter. Okay, we want to display the current count. Okay, so how we can do that? I can say counter text, so counter text that set, again I'm gonna use our set text built-in function. So now I'm gonna say f string because we want to use this counter, we want to use the counter variable, this counter variable here. Okay, so now I'm gonna say I'm gonna print like threshold count. Okay, sorry, threshold count. Okay, so I'm gonna say counter. Okay, counter. Okay, this is it. So we always want to see it, we don't want it to go off to so always we will see this threshold count. Okay, now let's see, let's define our RGB feedback. Okay, I mean, I want to say if the threshold is triggered green, means all clear or all alert, so we choose green for triggered. Okay, if field strength, for example, greater than 50% but not triggered, it will be yellow, warning, I mean. And otherwise just go to red, I mean, in the low field position, the SMD will go to red. This gives a nice visual indication of the magnetic field state, but it's up to you, how you want to define it. So I'm gonna say if trigger. Okay, so if trigger is true, then set I'm gonna now it's time to use this. Now we have to use this set RGB function that we defined here. Okay, so I'm gonna say if trigger is true. Now I'm gonna call the set RGB. Okay, now I'm gonna say 0 point for red, G1, and B 0. Okay, now I'm gonna say elif. Okay, elif. Okay, so elif, oh sorry, elif what? Elif hall val. Okay, if elif hall val greater than 50% or 0.5, okay, then what gonna happen? Then again, I'm gonna call set RGB. Now this time, red 1, G 1, and B will be 0. Okay, and the last one, so I'm gonna say else. So else if trigger is not true, means set, I'm gonna say set RGB. Now I'm gonna turn the red on. Okay, turn the red on, and the rest will be off. Okay, that's it. Now just let's just refresh our canvas, and at the end we have to add a delay. So I'm gonna say fig dot canvas, fig dot canvas dot draw. Okay, open and close parentheses, right? And the next line, I'm gonna say fig dot canvas dot flash events. Okay, open and close parentheses, and at the end, we need to just add short delay sleep in order to prevent our CPU 0.05 to get overload. Okay, so this is for our main loop. I think we finished creating our main loop. Nothing's left now. The only thing we have to just define our except block. So except keyboard interrupt. Okay, now I want to say, for example, servo dot write 0. For example, if you press emergency button, servo should go to the 0 degree, and the set RGB, I want to turn all the LEDs, I mean all three colors off, and exit from the program safely. Okay, open and close parentheses, and at the end we're gonna just print a message for the user. Program terminated safely. Okay, so program terminated safely. Okay, that's all. I don't think anything's left, guys, so I think now we finished coding. Now it's time to go and just run and test our program. Okay, guys, now let's run the program and see what's gonna happen. Okay, so I press the run button and we are waiting. Oh, there is an error. So it says invalid RGBA. Oh, I think let's check. Oh yes, hope you just shouted at me. I just mistakenly I just add an extra A here, so instead of black I said black, so just I deleted the extra A. Let's just run the program one more time. Oh, again it shows another error. What's this error? It says, oh, again I think I don't know why we made. Okay, yes, instead of double yellow, I just instead of W I just mistakenly I put R. Okay, so let's run the program one more time. Oh, again one more error. I don't know why we have so much of error. So let's go. It says list. Yes, see this needle line. Needle line is tuple. Okay, let me show you. We made exactly the same mistake in previous lesson, in I think lesson number 24. Now with the point. So here, because needle is tuple, so we have to unpack it in order to be able to use this let me see where it was, needle, this set. See, now it's working, now it's okay. So you have to put, this is a trick I told you in lesson number 24, I think. So I explained everything in details there. So you have to add this comma in order to unpack it here. Okay, to unpack it here. So here now we unpacked it. So needle line, that's a data xn and yn. Let's go and run the program one more time. So I press the run button and we are waiting. Oh, okay. So thankfully it's working properly now. Okay. So as you can see here, you know, now this is the, you know, semicircle, and this is the needle, and this is, you know, the degree of, it's showing, you know, the degree of the position of our servo. This is the magnetic field, and this is the threshold count. So now let's just approach a piece of, you know, magnet to the sensor. So this is the magnet that I have, and this is the sensor. Okay, this is our sensor, our Hall sensor. Now let me just approach the magnet and see, you know, the servo. Okay, see, as I just, yes, but you know, as you can see here, you know, when I approach the magnet here, you know, see, we want to just move our servo to, you know, to 180 degrees, and you know, the magnetic field, instead of, you know, increasing, it is decreasing. Okay, so now we can just solve this problem. So let's go to our coding one more time. So you know, in order to just invert that, you come here. Okay, here this is your Hall valve. Okay, in order to invert, you know, that bar, that rectangle bar, you have to invert your Hall valve here. Okay, how you can invert it? You can just, you know, subtract 1 from your Hall valve. It's very easy. So I can say Hall valve, okay, equal to 1 minus Hall valve. Okay, so this is how I inverted, you know, my rectangle, you know, the magnetic field rectangle. So now let's just run the program one more time and see the result now. Okay, you know, it depends on the strength on your magnet. So this is how your sensor just, you know, react. So if you have, you know, a strong magnet, your sensor just, you know, respond to it, you know, faster. And if you have a weaker magnet, your sensor, okay. So now let me just okay, see, now here the magnetic field is at it's showing 47%. Okay, but you know, you may ask, you know, why now at the beginning that we do not approach any magnet to our sensor, why it shows, you know, 47, or you know, some other, you know, numbers. You know, many Hall modules, you know, like the one that we have, the 4 pins that we have, they are designed to output, you know, a midpoint voltage at 0 magnetic field. You know, I mean, for example, you know, on 0 to 5 volt system, this is usually around 2.3 to 2.5 volts. So, you know, pi Fermata normalizes, you know, 0 to 0.5 volts to 0 to 1. So 2.3 volts, you know, it's almost, you know, something like 46, 47 to 50%. You know, this will be exactly, you know, what we are seeing here. So, you know, it doesn't mean that your sensor or your code has any problem. This is, you know, expected behavior. Your sensor is working normally. The important part is, you know, the change when a magnet approaches, not the absolute starting value. But we can fix this. We can just, you know, in our code, you can make it in a way that, for example, you know, it's gonna start from 0, but I just explained to you, you know, why it's showing from 47 or 46% or whatever you see here. It doesn't mean that our code or our sensor is has problem. It's exactly, you know, the way that the sensor works now. So everything works perfectly. But if you want to see from 0, we can, you know, make it in our code to see from 0. So maybe, you know, for the next lesson, we're gonna do that, and we're gonna fix that issue. So now let's just go and test our program and our sensor. So let me approach, you know, the magnet to my sensor, and now, you know, the magnetic field is under 50 and the LED is red. Okay, so I'm approaching. Yes, see guys, as I just, sorry, let me hold it here. Okay, so you just take a look at the needle. Okay, see the needle, see the change in the needle. Okay, see now it's 90. Sorry, it's because, okay, and see now it's 135, almost 35 degrees. And as I just, yes, see, it's working exactly the way that we want. Okay, so let me just run one more time, and so you can see the threshold count from 0 again. Okay, so let me run the program one more time. Okay, all right guys, so now let me just make it smaller because it's a little bit too big. Okay, so now here you see the threshold count is 0. Okay, now let me just approach our magnet. Okay, see, so now the threshold become 1, and okay, so almost 138 degree. Now let me just remove the magnet slowly. Okay, see the needle? Yes, it's working exactly the way that it should. Now let me approach the magnet one more time. Okay, now it's 85, 86, 88, 89, 90. Okay, and yes, 130. And you can see the movement of the servo. Okay, if you have a stronger magnet, guys, okay, if you have a stronger magnet, your servo will move exactly, for example, to 180 degree, because it's because my magnet is not that strong. That's why it doesn't move to exactly 180 degrees. And you see here the threshold count. So everything works perfectly, and hope you just liked the lesson today. So please let me know if you have any question or if you have any doubt about today's lesson, and see you in the next lesson.